shit. All right, everybody. PRI. Hey, is this stainless? Okay, chrome. Okay, just looks, just bare. So yeah.
Well, no, it doesn't look like that normally. Normally it's like a gray color.
Right.
But I took the time to scotch spray it all.
Okay.
So it gives it, the nice look.
Right. And is it like anodized or something, or would you just have to paint it then?
No. It's painted. Like this.
Yeah, it hasn't been painted. Okay. Yeah.
This will rust on.
Yeah. I was gonna say. Yeah. All right. Well, it looks awesome. It's a hell of a lot of good TIG welding there. So. Yeah. You got a nice jig, I imagine, then?
Yeah, this is it here.
Oh, that's the jig. Okay, yeah. Wow.
It's another guy, it's his design. We make all the type of components for it, so like the top, we machine in-house. Threaded packs for so long, we make the clamps. There's a number of fixtures that pull to the table, 4-link brackets and fixtures.
Okay. So is this a triangulated 4-link then?
No, this is a bolt-in, well, I guess technically you could consider that, but it's a bolt-in.
Oh, okay. Yeah. Because I see these are coming off at like weird angles, so down here, yeah. All right, cool. What's something like this cost then? Yeah. Okay. So this will transform a new IRS Mustang then to a solid? Okay. Oh, for a Fox body. Gotcha. Okay. Yeah. Okay. Cool stuff. Thank you. Yeah. I wanted to buy a SN95 at one point and put a supercharger on it, and then I just bought an LS1 car instead. So, yeah, it's whatever. yeah, exactly. So, but the Ford rear ends, though, so this is considered a 9-inch or 8.8? 9-inch, yeah. This is indestructible. Yeah, so. All right, thanks. How we doing? Oh, there's some cool stuff at this booth here. I don't know what they're calculating there. How much airflow you can get at certain RPMs based on your cylinder head data. Hey, can you talk to me about some of the software? Yeah, well, what's going on over here? That looks pretty interesting.
Yep. That is engine analyzer pro.
What's going on over here? That looks pretty interesting.
Yep. That is engine analyzer pro.
Uh-huh.
That is most 99% of it is for estimating the power curve changes from cam changes, engine specs, horse stroke, head flow.
Okay.
And runner lanes, like front end accessory drives, the bearing sizes, the friction. I mean, we get a lot of detail.
Yeah.
But at the show, we put it on this animate mode because it attracts more attention.
Yeah, that's what got my attention. Yeah.
Rather than just power curve. So,
Yeah.
but that's this.
Yeah.
Rather than just power curve. So,
Yeah.
but this is actually checking the piston and valve codes also.
Oh, okay.
Just visualize what's going on. Checks piston and valve codes. And you got 4 valves. The valves come in like this. And actually check the clash also.
Oh, yeah, you could do like Hemi style or Penta roof or whatever you want to call it. Yeah. So what data do you put in here then?
Well, like I said, I mean, it goes into a lot of detail. The bore stroke,
Yeah.
rod length, head flow, port volumes, intake and exhaust runner lengths, port volumes, a primer on the header and stuff, the X-step and everything. Weather conditions, fuel types, supercharger specs, turbocharger specs.
So will this give you a horsepower estimate based on math, not a dyno? Full power curve and better than a dyno, huh? Really? It's you got the science down that good, huh?
I mean, we have people all the time call up and say, I'm within 1%.
Really?
Dynos don't repeat what they repeat, but I mean, they know the dynos on the road.
Yeah. The road dyno is only so efficient, and the chassis dyno or the engine dyno, is a little more efficient and
So,
Yeah.
I mean, it's smooth. I mean, we have people swear all the time.
Yeah.
I mean, I know what's going on. I know we're estimating a lot of stuff.
Now, what if you have an engine that has like some trick variable valve timing type thing? Are you able to input that in there as well?
It depends on what you mean by trick.
Well, what I just mean is, you could vary either the lift of the cam or the duration,
Variable valve time.
yeah.
There is some variable valve time stuff in there.
Yeah.
So
Okay.
you can have it changed with RPM.
Yeah. Okay. So can you show me, a dynograph then? I
Nothing's running. The computer's behind the screen.
yeah. Okay.
So anyway, I mean, there's a typical power term for two different cam timings. This is just comparing two things. You can have, there's so much this thing can do, but I don't know what we did, but there's fuel flow and air flow for different timings. There's your head flow input. Here what we're doing is, two different cam profiles with different ramp ratings.
Okay.
So the specs at 50 are the same, but you put in different ramp ratings and you can just graph that out and see what the difference is.
Yeah.
We can do variable, we can do Valvetrain dynamics. Have you ever heard of Spintron? Okay, Spintron basically motors the engine and you put these instruments on the valve train so you can see when valve toss occurs or spring surge and all this stuff. We can do the same thing mathematically. And just put in your weights, your spring rates, your compliance in the valve train, which is really important.
Yeah.
So that's why you get stuff sticking up the valve train, that stuff. Different cam profiles and stuff. And we can tell, it looks like there's some valve tossing at 77 RPM. You say, well, what happens if I take 10 grams off the valve? Well, that pushes up to 7850 or something.
Yeah.
So there's a whole lot of stuff you can do in there.
So with this software, can you go look on the website of Comp Cams, Edelbrock, Lunati, and play around with it and put different cam profiles in and see how much horsepower you're going to make?
A lot of them preloaded.
Okay. So you could probably find the max horsepower you're going to make, based on lift and duration, but unless they give you unless you have actual lift at every degrees, it's going to be hard to, you'd have to measure that. Something like that, exactly. So, yeah. So you're using every tool possible to.
Yeah, but
You're like a doctor. You want to see the vitals of your engine. Yeah,
that's why I think like someone said, we also have this option that's called chain calculations, where you can take up to 6 different inputs.
Yeah.
And say, let's say intake center line. I want to sweep it from 100 to 120 in 40 steps.
Okay.
So let me exhaust. I want the intake duration and sweep it from 240 to 70
Yeah.
and 10 degree steps or whatever. And all those combinations, set it up, get the thing running, and it's going to try 3,000 combinations for you. And it's very intensive math. It might take 20 seconds for each run. So 20 seconds times 3,000 combinations is 8 hours or something.
Yeah.
You're going to let it chug away for 8 hours while you're sleeping. And it's going to come back with the best combinations for average torque, average horsepower, peak torque, peak torque. So you get to choose. And there's another option in there. But I need idle vacuum of at least 14 inches.
Huh.
So I don't care about my idle vacuum at all. And it's going to keep track of the best on the whole combination. So we set up so it can be a ton of work, and you can just walk away and let it try this combo while you're sleeping.
Yeah.
Lots
Okay.
of good stuff.
How about this software over there? You specialize in that one too, or is that his demo?
It's drag racing or certain track road racing over there.
So you're trying to calculate the instant center over there? Is that what they're doing? Okay. So yeah, you sell a lot of different programs then, huh? And
There's about 30 programs on that CD, demos and everything.
$1,000 you get all this stuff? Okay. Oh, demos, huh?
It's a lot more than $1,000 to get everything.
Yeah. Oh, okay. I see. Yeah. So you said there's demos, huh? So anyone could try it out? Okay. Where do you go to find that if you can't get a CD like I can?
Our website,
Okay.
performancetrends.com.
Performancetrends.com. Okay. So solution for tell me exactly what's your sales pitch? What do you do for cut people?
Tools for racers and engine builders.
Tools. Okay. I like that. Yeah. Okay. Nice talking with you. Thank you. Uh huh. Well, that was pretty cool. I like all that nerdy technical stuff, you know. You can only go fast. You can only go so fast with just throwing stuff on your car, and there comes a certain point where you gotta optimize things. There's a pretty well-known car, the Blasphemy, built by Freiberger. It's I think it's a Tri-5 Chevy with a monster Hemi under the hood. They had it open yesterday, not today. Quick question: has Freiberger come by yet?
He has not that I've seen.
Okay, I know he's coming at some point. Let me just take a look at this then.
He's coming at 2.
Yeah, 2 to 3. Okay, so all right, thank you.
50 people get a beer and a T-shirt.
Really?
Really.
What's the T-shirt look like?
I think it's one of the Red Tail T-shirts.
Okay, 2 o'clock. 2 o'clock then, right? Okay, I will be here for that. Thank you. Yeah. Late model here. Some Hemi heads here. Billet. It's got a water jacket in it?
I don't know. Does it say it does?
Oh, I'm just looking at it. I don't know.
That one does not.
Okay, I didn't think
That's
so.
an
Yeah.
alcohol.
Yeah.
That's a Noonan. We make a rocker and assembly.
Oh, okay. Yeah, Manton push rods is your name. So Valvetrain stuff. Yeah. Okay.
We made
Any-
that rocker assembly.
Yeah. Any new innovations?
Not what?
Yeah. Can you show me some?
It's an 81X,
Okay.
and we just built a rocker assembly for it. If you go to the other side, the rockers will show through a plexiglass shield.
Okay.
It'll be
That's
nice
pretty
looking.
cool. Yeah. You don't have that on display though, huh? Do you have that on display with the plexiglass where you can see through it?
Yeah, you can see it right now.
Oh, okay. I see what you mean. Yeah. I got a look here. Now, how do I crank the engine over? You got a long lever,
Have good grip. Move though, believe me.
but it doesn't run like this. So I see that there's some gaps in here. This is just for show.
Yeah.
Okay. Yeah, you'd be spitting oil all over the friggin' show if you tried that. So. All aluminum. Wow. Okay, thanks for your time. Manton push rods, rockers, belt trains. Oh, a Weewa. This may as well just be called the jewelry show. How you doing? What are you showing off here?
Oh, you just got it.
Oh man, stainless?
Yeah.
Ooh, I like this, nice and heavy, and yeah. So this is for a 6-cylinder engine, a 4-cylinder engine, and a yeah. This is awesome because I always thought it's really hard to probably weld, you know, inside here and in here like this when you're trying to make this out of tube steel.
Yeah,
But when you CNC machine it, it's kind of like the possibilities are endless, right? So.
yeah, to some extent, yeah.
Yeah.
Another benefit of it being
Well, we'll go here.
this was actually part of the manufacturing process, so that this side was machined first, and then it was bolted to a fixture.
Oh, okay. I was gonna say I don't think you'd put like a O2 sensor in there, you know. So, I mean, yeah. Sure, it could be done though, but you could have a reading right here if you really wanted to. Yeah, that'd be kind of cool, right? Yeah, right here is how I was saying it. So what we got a blow-off valve built into this one, or a wastegate, right?
This is actually something a little special. It's a prototype. It's basically like a screw valve where you block off one of the screws for low RPM, you get higher velocity, and then you open up for higher RPM. You open up the valve, and that will all work.
Okay. Never thought of that.
You get
Yeah,
a
that's
variable AR ratio on your turbine housing.
right. Okay, so it's for all these years I've heard about the sequential turbos that like the Supra and RX-7 had, where they had a small turbo and a bigger turbo, and they spool the smaller one first and then the bigger one, and then there's your anti-lag system. So this is another way to optimize peak power
Yeah.
at all RPMs, but you have to have a specially designed turbo. This one won't work for that. That's
Yeah, you have to have a dual.
you don't have a twin scroll one here, on display, huh? Okay, but I think everyone knows what a twin scroll is. It's pretty modern these days. So okay,
So one of the nice things about having a CNC machine is consistency. Like if you're making a large number of manifolds, like this piece is always going to be exactly the same.
yeah, okay, great stuff. Where do people go to find your products? Okay, Elmer Technologies, huh?
ElmerRacing.com.
Elmer Racing. Okay, where are you guys from? Finland. Okay, were you here last year? Did you have the 968 motor on display?
Oh, we have a Thor engine.
Thor?
Yeah, that's the same one. Yeah. So
Yeah,
probably the same
it's the Porsche, right? Yeah.
Yeah. Well, so this is the prototype engine they have in the RP968. That's what the time attack now for 2 years consecutively.
Yeah, and it's 4 liters, I think, right? Okay. Who designed it?
I do the design work on
You did the design? Can you tell me a little bit about it? Like what kind of upgrades you?
Well, the whole thing, the main point with this whole engine is having a low weight on that. So you get, high power circuit racing engines. There are lots of manufacturers that do those.
Yeah.
The main point of this is having that in a really compact and lightweight package.
Okay.
So the log block weight of this is 106 kilos. And that's including the vibration damper and the wind pump, and the price and pump, of course.
Yeah.
And so this is fully designed from the ground up to the racing engine, really. So
Okay.
there's no oil pan, for instance, at all, and it's fully designed for price and use only. It's a compartmentalized crankcase that has its own extraction for the price and oil pump. The oil pump for the cylinder head does not go into the crankcase at all; it goes directly into the suction pieces to the oil pump.
Wow.
Consistent high G turns very easily, and there's very little load to be aerated.
Yeah. And then Porsche, they slant their engines like 30 degrees, right? In the okay.
Yeah, so that is
That's-
basically, you can vary that around depending on what engine bay it's going into. So
Yeah.
yeah.
Okay. Now I just always thought that was weird on the turbo Porsches where they had the turbo, routing underneath the engine.
Yeah.
You know what I mean? The hot side, and that just creates lag, that creates heat. So I was wondering, is there a way to solve that? You think, or would you have to?
So this, compared to that engine, this has the intake and exhaust on the opposite sides. So this is on the other side has the intake and the exhaust side, on the side of the exhaust space.
Okay.
For ventilation to the layout.
So do you just flip the cams then? The intake and the exhaust are opposites. Oh,
Of course, the intake and exhaust cams, of course, are opposite.
and the valve. So it's like a mirror image then, sort of. Yeah.
Cooling system is also
And does it have the vario cam in it?
no.
No more variable valve timing, huh?
Yeah, I think, I don't remember exactly what. Isn't the intake probably that is variable on the Porsche engine, I think?
I'm not too sure.
They have a
Yeah.
drive on isn't the drive on the exhaust side? Because I know that the variable stuff is like internal in the cylinder head. Because they drive one of the camshafts from the other camshaft with the chain internally, and then they have the variability on that to tension the chain differently to get the cam timing varied on the other camshaft.
Yeah, they could change the degrees by I think like 30. Oh yeah, and so
Yeah,
cool system when it came out in 1989 or 1990, whatever year it was. Yeah. So
for race engines, of course, that's like that.
so you said it's got a vibration damper on it then, huh? And it's different than just the normal harmonic damper, or it's
Oh, it's the same basically.
same thing? Okay, and it's mounted in the front or the back then?
So it goes,
Yeah.
so this is on the front of the engine, so it's a really thin one, large diameter one to get enough inertia there.
Yeah.
So it mounts on here, and then the cam drive pulley comes on top of that, and then the oil pump pulley on top of that. So
Yeah. So how'd you guys get this here? Did you put it in your suitcase in your carry-on? You took it apart?
So 2 years ago, We did bring it here actually as a checked-in luggage on there.
Oh my God.
That has a, I think it was 132 kilo, and so that's the maximum weight limit you can check in.
Yeah.
Flights. And then 23 kilos is the like normal baggage limit. And then we brought 2 of those at 132 kilos or something like that.
Did it have a problem when it went through the X-ray or? No? Okay. Yeah.
But it's, good to have like components that are so lightweight that you can actually like split the engine apart and go.
Yeah. Because I've done trade shows here before. I worked in the woodworking industry, and they charge us so much money to just take the products off the truck and forklift them, over to our booth. It was like $6,000 to take 4 woodworking machines. The union just charges whatever rate they want, and you can't help them. And so that's good that you were able to bring this in pieces, in your luggage and stuff like that. So, have you sold any of these yet, or just the prototype?
Just
No.
the 2 prototype engines so far.
And are they being used though?
Yeah. So
They are.
So the RP968 has. So yeah, they've run now 2 years consecutively with our engine and won the World Championship in both those years. So
Wow.
Doing good.
Okay.
So we have 2 engines also for our ERH car. This is one of those.
Yeah. So I know in the
parts.
Porsche 928, one of the downfalls is that they have the open deck, the cylinder walls. They don't have any strength in the cylinders and in the cylinder head. Or it's the cylinder head that keeps it clamped down. Do you know what I mean by that?
Yeah.
So do you have a closed deck on here then?
We have our.
Or is it filled or?
Solution for the cooling system.
Yeah.
But it's not a closed deck, but it's not really open deck either. It's
Okay. It's kind of semi. Yeah.
It's kind of custom design.
Yeah.
That working. But when you hear lots of people talking about you have to have a closed deck and like how thick it needs to be, and like it doesn't really work that way.
Okay.
Because especially like when you have the pistons at the top of the board, there's virtually no side loading at all.
Yeah.
The side loading is when the piston is further down the board.
Right.
If you're like having problems with the top moving around, then you have some serious design issues or stuff like that. So
Okay. Well, I think boost too. If you put a ton of boost in there, you're more likely to blow the cylinder head gasket. I mean, I'm not an engine builder, but I just no.
So this is we just run completely plain MLS gasket on this.
Okay.
So nothing special with that, but the head mounting is designed integrally. So we have the block are designed together to distribute the clamping force between the bolts so that they're evenly distributed around the cylinder board. Because when you hear people talking about lifting heads, I mean that means absolutely nothing. As long as you're not like snapping the head bolts or like pulling the threads out of the block or something like that, you're not actually lifting the head. The head is not moving anywhere. It's just that the clamping forces are designed so poorly that you don't have like a force clamping the gasket together. So then the cylinder pressure pushing out on the gasket is causing it to fail. Really, if you have. That's typically what's happening when you hear people talking about lifting heads or something like that.
Okay.
There's nothing with the head lifting to do at all. Try to alleviate that with running like larger head studs and clamping it harder, and then that typically makes the problem worse.
Yeah.
Because
you could warp it, right?
The head bolts, you just clamp that harder, but then between the head bolts, depending on the design of the components, you might have like even worse situations where you have even less clamping go like between the bolts.
Yeah.
Due to that, so it's not. It really needs to be designed as a complete package, really, to get the best possible sort of functionality.
Yeah. When you bore the cylinder walls out, do you put a clamping deck on there? Do you? And
this it's not really used. I mean, I did some comparison calculations, and the differences are so small that it doesn't really make sense.
Really? Okay.
To spend extra time, but that depends also. So if you're running studs with really short threads, or depending on how the block is designed around how those threads go in, there can be significant warpage there.
Yeah.
That is so that's around the thread area where the studs screw in. That's where you're going to have warpage. At the top of the cylinder, you're typically not going to see any difference there at all.
Yeah.
But this is the design of this is really good. So there is a very, very small differences. So there's really no need to have a torque wave out there.
Okay. So what software did you design this on?
So we have SolidWorks for CAD and FEM, but basically, I mean, any CAD software nowadays does the exact same thing. So.
Okay. And did you do the finite element analysis then to figure out optimal strength? I could see you have a lot of ribbing in here, and
Yeah.
I could tell that that's someone really did their homework making this.
One
So
of the externally visible things with the head gasket clamping, specifically this cut here.
yeah.
So of course this is not here to reduce weight or anything like that, because it's like way too small to actually do anything beneficial. But this depth and this angle and the shape of this is designed specifically. So this corner head bolt here and this corner. So looking at the loads here, we would have a like wasted clamping force on this outside of this surface here, and not along the inner edge of the cylinder bore. So this cut is put in here to make this slightly more flexible. So when you clamp the cylinder head, so this will flex inwards, and you will have the clamping force distributed more along the cylinder bore instead. Clamp that down, and that's basically the whole philosophy, is like the whole engine. That's one of the externally visible components.
So how far do the head bolts go?
They're going really deep. I think they're
Going really deep?
around. Oh, I can't really remember. I think
Okay.
they're
So
about this depth, something like that, maybe.
one thing I saw, Wagler, he does kind of the same thing you do for like big engines, diesels and stuff like that. And one thing he had is that the cylinder head bolts go all the way through the block and through the bed plate or the oil pan, so the whole assembly is clamped together. Is that something you've ever considered doing, or?
We thought about that. There are there are of course some benefits if you're using like cast components and you have issues pulling threads out or something like that.
Yeah.
But with engine design from scratch, it doesn't really make sense to do that, because you're losing so much design freedom on where to put the bolts if you're running those through the whole engine, and also it makes it impossible for well you can't have like these screw-in sort of stud things that are like a single piece going through the whole engine, but it makes the whole engine like so much. It like limits so much what you can do with the design on that doesn't really make sense. So we use really high strength alloys also, so it's virtually impossible to pull the threads out of that, because the size bolt you would need to be able to pull the threads out is like larger than what the thread size is, so you end up snapping the bolt before you can pull the threads out. And also, so getting the deformity around the threads when you clamp that down to be very low, to shorten the cylinder bore as low as possible.
Wow.
I don't think that we just do internally the design immediately, so during the design process, so there's no need to do this like aftermarket tuning stuff and run these like stud things through the whole thing, because there's no real benefit on this type of design to do that.
So how much time do you think you have in this, in designing it and machining it? And
So we did extremely efficiently. So we did this complete engine, basically from scratch. The design plus the prototype manufacturing took about 8 months or so.
and that's working how many hours a week full time at it, or?
Probably around 120 hours per week, something like that.
Okay, so this is kind of your baby then. For 9 months, you grew this thing, and or 8 months, whatever.
It's not only my work, of course. I mean, Axel did all the manufacturing
Yeah.
stuff and helped with that a lot. And we had a guy that worked with us to help with the CAD stuff. So, but it's not like when you sort of start comparing it to other engines. So performance-wise for a circuit racing car means power to mass ratio really. And compare that to the other comparative engines, so that would be like the V10 Formula 1 engines, were the previous record holders for the highest power to mass ratio. And, so this Thor engine beats that.
Really?
The V10 Formula 1 engines, they have like factory teams.
Well, but those are naturally aspirated though, so.
Yeah.
So that's
You have to really take a little bit of design. Defining what you can do and can't do.
Yeah, a lot of regulations. Yeah, no exotic materials and.
For like 5+ years, and continuing to improve those. I have like a huge team spending millions and millions on that, and we did this with a 3-4 person team on operations.
Okay. Any other projects you guys are working on?
Well, our control electronic stuff is not really something that we're probably bringing to market, but basically developing technologies, and then we're seeing if that's maybe some other ECU manufacturer maybe has use for the technology involved in that. So
Yeah. Well, what is this big black box here? Is this the thing on an airplane that when it?
Basically, just need to plug that into our. Basically, a showcase to flash the LEDs here, but it's not plugged in yet. Just got this so late yesterday that we haven't sent it.
Okay, so that's supposed to be a model of an engine then, right? Yeah.
Yeah,
Okay.
so we have a high power analog output source also.
Yeah.
This is a test unit, we're not a prototype yet. A prototype would be the correct size, and this is like really testing it. So figuring out what kind of electronic components we need in there, and now that's like there's probably about 75% air in here.
Okay.
But yeah, we do have so 8 high power analog outputs. So we don't do a PWM outputs, for instance, for control, so that's why we want to have a trial body here. So you can run that and adjust that, and you don't have this like squeaky, this high frequency electric pitch noise that you hear from all other aftermarket ECUs that run drive-by-wire controllers or something like that. They run PWM outputs, and then that creates this high pitch noise, and that also creates noise in the electrical system that you need to filter out from all kinds of components.
Yeah, so you're using pulse width modulation then to just vary the throttle continuously? Is that what it's doing, or?
Yeah, so the PWM output is basically for throttle control. They typically run that at 10 or 20 kilohertz or something like that. So they basically pulse the output from the ECU. So you have like 12 volts, and then it goes back down to 0 volts, and then how the distribution of that, like how many percentage of the time it's at 12 volts and what percentage is at 0 volts, basically dictates like how much the throttle is open, and then it just pulls that so fast.
So it's kind of the average.
That it doesn't like respond to those pulses.
Yeah.
But it responds to the modulation of how much of a percentage is on and how much off.
Okay.
And that ends up creating electrical noise, and that ends up also creating this like high pitched squeak noise that you hear from the motors when you do that.
Huh, I didn't know that. Okay.
So we run that with the analog output, so you have a very, very little electrical noise. It helps a lot with the response to the sensors and onboard inputs and stuff like that. Also with the analog stuff we do on this is completely insane.
Yeah.
I think this is probably even better than the incredibly expensive ECUs that you use in F1 and LMP1 and stuff like that.
Yeah. Can you open this up?
Theoretically,
It's all bolted, huh?
It's a little bit complicated.
Okay.
So
Yeah.
really, I mean, it's just like we have a large basic baseboard with just stacked like prototyping boards on top of that. That's why it's so big. So and then, for those prototyping boards, we have those for the high power analog output. So play around with those, and we can swap those out quickly when we're like in the testing stages to get this to figure out.
What's your education background?
Actually studied at the Helsinki University of Technology. 10 years our U.S. U.S.-based student assistant.
Yeah.
Does that kind of stuff.
You're the apprentice. So, I mean, so you have a master's in electromechanical, or?
Well, I would have if I would have completed my studies, but
Oh, yeah, okay. Because
still a student.
yeah, that's kind of what I want to be, a student for life, you know. But never stop learning. But yeah, you seem to know a lot about, manufacturing, electrical stuff, and just engine theory. So yeah, it's
I mean, a super good expert at any like specific
yeah.
detail.
I know, it is so weird.
Get from designing stuff is if you know sort of enough of almost all the categories, so you know like, okay, you need to solve a problem. So is it easier to do it like this way or whatever way that is?
Right,
so
right.
You figure that out. Okay, yeah, it's easier to do it this way, and then you figure out, okay, do we need to get someone to do this, or do I know enough personally to be able to figure that out? So if you're like focused on just one particular detail and being very good at that, then yeah, you might end up like spending 10 times the amount of time to figure out how to solve a problem that way instead of like doing it some other ways.
Okay.
So like with the electrical noise, for instance, with the ECU stuff, yeah, you can choose components to run or run PWM control or run analog outputs, or there are like all kinds of different ways to solve problems, and like understanding enough of the details to be able to figure out what is the most efficient way to do that is really important.
Have you had any requests from anybody to build an engine?
We have, yeah. We're looking at multiple different possibilities to develop it further. And of course, for racing use, yeah, we've had lots of calls on that. So
Okay.
surprisingly, also for normally aspirated use, even so.
Yeah.
There are some the rallycross categories where they have a maximum 4-liter displacement normally aspirated engine, for instance.
Yeah.
And well, of course, weight is always critical, so that would be a really good use case for this, for instance. But I think
Okay.
probably drag racing would be maybe a good use case for racing stuff. Yeah, we're looking at other markets also, so aviation markets for that engine.
Okay, experimental aircraft stuff. Yeah.
So it would be fully certified stuff.
Certified stuff?
Yeah, yeah.
FAA certified stuff?
Yeah, yeah. Or we would certify it. We're from Finland, so we'll operate in Europe, so it would be EASA certified.
Okay, I just know to do that, you're looking at spending years and hundreds of thousands to get stuff certified by the FAA. So,
we're
yeah, that's
currently in the process of starting a new company to do that development. And,
okay.
I mean, yeah, currently it's a racing engine, so it's been tested to do about 10 and 15 seconds at full power.
Yeah.
And then you're in a braking zone and stuff like that. So that needs to be brought up to about 2,000 hours for cruise power, which is about 80% of the next power, something like that. So,
Yeah.
so yeah, I'm estimating about a 2-year development project to develop this to
Okay.
that stage. And we're in some discussions to get financing and get the right people to do that. So it will be a new company with about 15, 20 people to develop that over 2 years.
Have you ever been to Oshkosh, Wisconsin?
No, I don't think so, no. Is that
Oshkosh.
trade show, I think?
Yeah, I think it's actually in terms of the amount of people that come, I think it's actually the biggest show in the United States. It's like 700,000 people show up there over the course of a week, and they have all kinds of people that are building billet engines and people that are taking engines out of Corvairs and Volkswagens and putting those in planes. So yeah, you ought to check it out someday. I go there every year. I'm a volunteer there. So if you're ever interested, let me know. But
Yeah, so we were at Avalon Air Show and Paris Air Show this year to speak to aircraft manufacturers there directly. And of course, you always expect there to be like the vast majority is going to be saying that, yeah, well, we have this and we're not going to change anything ever. And you always have a huge resistance to change, of course, always, and that's to be expected.
Yeah.
There's a surprising amount of people that were like, yeah, sure, if you can build an engine that has a better fuel efficiency, so we can get a longer range or higher waste carrying capability of running the same aircraft, I would be super interested in that. So, yeah, surprisingly, a high percentage of people that I spoke to, they were interested in that. So,
okay.
yeah, that made us sort of more confident in putting our time into moving forward with that project and see if we can get that off the ground. So, and looking really good for it. So.
Yeah. Okay, so whose idea was the variable scroll turbo thing?
That would be, well, me and Axel probably. So Axel does all our collector design and manufacturing.
Okay.
And yeah, then sort of design-wise to use a wastegate for the second scroll is
Yeah. Because I think this is just fascinating right here, and you haven't put it in use yet though.
No, it needs to be tested on a car.
Tested.
That car actually finally got finished, I think, this week or something like that. So as soon as we get back to Finland, we have some details to figure out with that, and then we'll start testing it on a rallycross car.
Yeah, but I think. I mean, are these being used in rally then?
Not yet.
Not yet?
First prototypes.
Okay, I think this is a really sophisticated idea,
Yeah.
and I really think that there's an opportunity to grow this.
Yeah,
So.
we definitely need some further development stuff.
Yeah.
Like that, but this is like, yeah, the first.
Just wondering if that would be
Okay,
more,
well,
on the
do you know? You ever heard of Torque Amp superchargers? No. Okay, so it's an electric-powered compressor essentially. So it's an electric-powered supercharger, and it relies on a 48-volt battery system. And yeah, he debuted it at the SEMA show in 2018, and I was the first person to interview him. And he's had really good success. He kickstarted it. He went on Kickstarter, had a crowdfunding, and he already has 50 orders. So after only over a little year and a half, he really brought his project to life. So I'm hoping that maybe the same could happen with you guys here, and someone will see this and they'll like it and they'll contact you, and you'll get an order for 1 million of them. So, yeah. All right.
Well, I mean, if we don't make it, then who else is going to make it? Because we're the only company we know that does bill of parts collectors and capacity. Do the design and figure out how to get it to a sort of economical way and do different designs for those who use the flow to the second scroll tires and then designs.
Yeah. Okay. So how can people find out about your products? Where do they go? You got a website or?
Yeah, elmaracing.com.
elmaracing.com, right there, guys. Okay.
Yeah, Twitter, Facebook.
Twitter, Facebook. Okay. All right. Thanks for your time, everybody. Nice meeting you guys. Nice meeting you. Yep. So how'd you guys form the name, by the way? Is it? Wait, you guys are brothers? Oh, okay. So that was pretty easy then, huh? You just took a variation of your name and. Yeah. Okay. Nice meeting you guys. Thanks for talking with me. Uh huh. This is pretty sweet. Hey, if you guys aren't busy, can someone tell me about this thing here?
It's a Hellcat intercooler.
Can I film you? Yeah.
Not really. Come on.
No. Okay. Can you talk about it and I'll just film this? All right. All right.
Hellcat intercooled intake manifold replacement.
Uh huh.
So if you want to go single turbo, twin turbo, or put a supercharger on it, it's got an integrated intercooler.
So the intercooler is here or down here then, or the whole thing? Okay.
It's a
Water.
3-stick Bell intercooler.
Yeah. Okay.
You can get it single injector, dual injector, nitrous spray bar, or set up for nozzles for a fogger. Even meth, you can get they can put spray bars in it for that too.
Mm-hmm. Okay. And will this fit under the hood of Challengers, Chargers, and stuff like that?
Yes.
Yeah. Well.
And then the snout is universal. You can pretty much use any different throttle body. Like it's got the Hellcat flange on there now, but if you had like a 6.1 or like a Whipple oval or something like that, they can be adapted to it.
Yeah. What's this cost?
Starting at $62.
Okay. I got a Jeep SRT with the 6.4. Mm-hmm. So would this work on it?
Yes.
Yeah.
It would need. This manifold can also be adapted to the standard bolt pattern just by changing the flange. So it's pretty modular design where it can go on the Hellcat, how it's sitting now, or it can go to the older style with changing the bottom flange.
Yeah, because I think I heard that the Trackhawk is a level above my car, and I was like, hey, I wonder if I could just get the supercharger and bolt it on. And they said no, that the heads are different. So I don't know if it's just the size of the ports or it's
the bolt pattern is different. There's
bolt
a
pattern,
and then the Hellcat pattern is the up top 8mm.
Yeah, can we look at it?
Yeah.
So tell me again, what's the difference between
on the Hellcat's a top pattern.
Top pattern.
And then the normal Hemi pattern is the bottom pattern.
When you say top pattern, what do you mean again? These right there. Okay.
This is the Hellcat pattern, and then that's the standard Hemi pattern.
Ah, okay. But the size of the ports is the same?
Yes.
So it's just a stupid. So can you just bore and tap it and?
No.
Oh, you can't.
No, there's nothing on. Like this is my older style head.
Yeah.
There's no bosses or anything above them.
So can we tilt this?
Yeah.
So you said you can't just drill new holes in here then?
No, there's no material past.
There's no material. Okay, so I see what you mean. So I could put my hand. I'm putting my hand here right now, and it's like
nothing.
Yeah.
Where the Hellcat stuff, there's actually bosses on top.
I got you. Okay, so maybe if you did some sophisticated, welding and adding material in there, but at the end of the day, it's it's not going to work or not. It might. Yeah, sorry.
And then there's a couple of people that make adapter flanges, but then they're like 3/4 inch thick.
Gotcha.
So it moves everything back up.
Yeah. Okay. Cool. I learned something new today. So, how many have you sold a lot of these?
No.
No.
They've got a couple in prototype. We got about 25 of them made.
Yeah.
They've done some testing with them, but none that I know of that are actually out and about yet.
Gotcha. Okay, well, if they're taking up room, I'd be happy to borrow one of them, put it on my Jeep, and see how it works, So, yeah. Where can people find out about your products? HHP Racing?
HHPRacing.com.
Okay.
ctech.net.
Yeah.
And then also Facebook.
Facebook. Okay. Thanks again. Nice talking with you.
Yeah, did you see the turbo?
Mouth is drying out from all this talking.
Shirts look good. Purple haze.
Howdy. Pretty good. I'm filming for my YouTube channel. I came across this. I think it's pretty fascinating. Would you be interested in talking to me about it?
Sure.
Okay. Can I film you?
Sure.
All right. So what are we looking at exactly? Siamese.
Yeah, we call it a DCI, ducted cylinder insert. It's for this is for our Hayabusa block.
Okay.
It's all interconnected sleeves. It kind of
All the sleeves? Yeah.
Yeah, it helps the rigidity.
Okay.
Keeps the block from flexing when you go to the big board.
Yeah.
Deal.
So yeah, that side loading is spread out amongst the whole block, as opposed to just kind of one cylinder. Yeah.
When you put the flats on, an individual sleeve has a tendency to move. It loses its rigidity.
Right.
And where the flat spots are, it'll tend to shift around a little bit. That's
So yeah.
just one piece.
And probably I would think that the expansion, when you have individual ones expanding and stuff, they're pressing against each other, whereas the whole thing, yeah, it'll stay more rigid, I guess. So this is ductile iron then?
Yes.
Okay. And you guys just machine this then, or?
Correct. Out of a solid.
Yeah. Because I had always heard that sleeves were spun centrifugally or some crap like that.
Continuous cast with the solid bar stuff.
Yeah.
We'll actually scale this sleeve out, and then you can get them both ways.
Yeah. Okay. Do you do any type of heat treatment or coatings in here or anything like that?
Not on this product. We do heat treating. We'll heat treat ductile to a harder, spec. But
Yeah. Okay. And so far, is the Hayabusa the only thing you've done this on, or? Yeah.
We tested with one rider.
Yeah. I think there was one automotive manufacturer, maybe Volvo, that has done something like this in their engine blocks. I don't know if you know about that or no. Okay. That's what I heard. There's a guy on the internet who does Porsches. His name is Strosek. I don't know where he's from, somewhere in Europe. And he built a Porsche 928 V8 engine with a similar thing like that. So yeah. So I thought that was really cool. I thought there's just tons of advantages to this, and I never understood why Darton or LA or all those other guys haven't done stuff like this.
You know what I mean? And it's just
that is true, and it's always custom to your application.
Right.
Because you could sell the sleeves and different boards and stuff like that, but with this, you have to bore the block out to. I mean, did you bore this block out then? You did.
Yeah.
Okay.
Yeah, the bore block to match the design of the sleeve.
And this is water cooled then, right?
Yeah. This block is filled. So,
filled with halfway or all the way?
Well, we haven't filled this one, but the one that we're running is filled.
It's a drag race bike. Is it that bike right there?
No, that's a top 200.
Tough. Oh, I didn't look at it yet. Okay. Any other cool innovations you guys have?
Just we do a lot of custom things,
Whoa, what's that for? Jeez, bulldozer or a tugboat? Tractor pull? Okay.
Yeah, so we'll do, we have a tractor pull stuff. We do, old vintage motocross. We do Snow Pro mod sleeves.
Yeah.
We'll actually make
Wow. I never knew that they were that big. That's nitromethane that goes in there, right?
Yes. Yeah.
Yeah.
So it's all we kind of we'll do anything.
Yeah. The driver's not here, is he?
No, he just went to lunch.
Yeah. Okay. Maybe I'll come back then and he could tell me about this.
Yeah, come on back.
This fucking. I don't even know what to call this. I think I just call it. I would call it a death trap, but I don't want to jinx the guy, But yeah, I like that. God Jesus, man, because I'm scared to go above 150 in a car. I couldn't imagine doing 250 on a bike and accelerating to the point where your eyeballs are, stuck in the back of your head. And yeah. If one of those pistons came out, man, it would take your heart. It'd go through your heart. Yeah. So. Yeah, nice talk with you. I hope to stop by. So where do people find your products?
Vansleeve.com.
Vansleeve.com. Check them out, everybody. Okay. Thanks for talking with me, man. Yeah, hope this takes off, and I hope you guys make a fortune.
Cool, thanks.
Yeah.
Bob, I want to tell you, man, thanks. That was good, Jeremy. Thanks, man. Appreciate you guys stopping by. Thanks.
Oh shit! Look at all this money here. I'm just kidding. Who's the driver? Yeah, is he around? Yeah. There. Okay. So, tell me, is this faster than that, or like the two different?
By far.
Really?
Oh yeah, by far.
Wow.
265.
Yeah.
In a mile. Somebody else.
Oh, in a mile.
In a mile.
Okay.
That bike is quicker.
Yeah. It's acceleration. Yeah. That's what I meant. Quick and fast. Two different things. Yeah. So. Okay, and this is using. Is this a Honda or Yamaha? I can't tell.
This is a Suzuki Hayabusa.
Oh, it is a Hayabusa. Okay.
It's with simple fairings, a 3/4 fairing, and 277 downstairs. Standing miles.
Yeah. Tell me about the engine block.
The engine block is a stock Suzuki oriented component.
Really?
With Modular pistons, Modular rods. It's got his core here. The owner actually builds, supports, tunes.
Yeah.
Sells,
Yeah. Okay. How much boost does this thing run?
and we're driving up there at 700.
Okay. Wow, 700 on a machine between your legs. Yeah, that's shit. My jet ski puts out 100. So Yeah.
I followed at 50 on the line, and it still hurts.
Yeah. So, okay, cool. Thanks for talking with me, man. This is a heck of a machine. You're the driver? Props to you, man, for yeah. So what's this system right here? Does that control the handlebars from shaking at a high speed, or?
No, those are these right here.
Yeah, that's all you use, huh?
No, actually, this is CO2. So this is going to do a couple of things. Number one is going to be boost control strategy.
Okay.
What's up, boss?
That's connected to the AMS 2000.
And
Oh.
they're putting cash everywhere? Is that what it is?
Okay.
Tickets to the so it's going to go to 2 solenoids here.
Yeah.
Based upon CO2 here, it helps regulate the pressure inside the wastegate.
Okay.
Second thing, it ties off. It goes this way. It's moving over to a plunger or a shift solenoid.
It's a good
Yeah.
show. No, I sold it for 20 years. So.
Right
Yeah.
down there.
Okay.
Is there any chance we can,
When it works
get
right,
you guys
you
anytime?
can hit the button. I can shift gears.
Oh, so you got a sequential style.
That's what
So you're not having to use the clutch then?
No, the only time we use the clutch is to leave, and that's the way any motorcycle clutch is, right?
Yeah.
Once you're actually involved in the pursuit,
Yeah.
that's not necessary.
Okay. Yeah, it's got dog gears, or yeah. Right. Okay.
Sure. And as far as the turbo kit, the initial foundation is RCC there in Canada. RCC Ultra 1000, larger core. We've got turbo from Bullseye Power, turbocharges, Will, and Danville Performance did all the machine work on the turbo. And then STPI, which is my shop, put it in a nicer package.
I'd like a piece of meat or a piece of cheese.
Everybody else is represented as DMV Swing Arms. They're from North Carolina.
I know.
They built a custom swing arms that we can hold some lead ballast
Yeah.
for traction purposes.
Oh, really?
Brock's. Oh yeah, you can knock on it. You can tell. You take the caps off and you can see a bunch of number 8 lead shot. This has about almost 50 pounds in it, plus or minus depending on the conditions we need. If we need more weight, there's also some lead underneath the bottom of the bike.
Okay. Want low center of gravity, huh?
Yes.
Yeah. And then a carbon fiber wheel I see here. That's a nice piece.
Oh, from Brock's Performance out in Ohio.
Okay.
BST's manufacturer.
Yeah.
So it's a little, Brock's is the North American rep for the BST brand.
Okay. All these guys sponsor you then?
They do help out quite a bit.
Yeah.
Without them,
That's
it'd be
nice.
a lot harder. Mark
Yeah.
Turnway is actually the primary owner of the bike.
Oh, hey, nice to meet you, man.
Yes, sir. Yeah, we pretty much all the stickers that are on the bike are the guys that help us keep going and doing what we're doing.
Yeah. Okay.
We're getting closer to what our objective or our goal founding the composition of the building of the bike. We're getting closer. The initial foundation, the first contractual obligation between me getting the bar was to go faster than 2.5 naked, so we've already exceeded that.
Yeah. So why naked? Why not? Why don't you have fairings on it? Or
Oh, we've actually run, I mean, the 277 pass was actually done with 3/4 fairing.
okay.
We have a full APS configuration. We do have a body work for that.
Yeah.
But it's more about
Really?
They look prepared for the opposing ring forces the faster you go.
Yeah.
And it's honestly, and the guy, honestly, the guy we're racing has already spared for him. He's the fastest guy to be able to
But that's the thing with carrying.
his world record is 296.
Wow.
So generally, even if you're going to pay your bills off, you're going to do something you start with the easier ones first.
Yeah.
His world record naked was 255. So what we did was walk that
anyway.
first.
Okay.
So it's still like we're continuing the conversation and friendship through racing.
Yeah.
That was the first one. We went 262. We went on record by 265. It's still it's fast with no body work.
Yeah. So what you're saying, I think, is you ain't done yet. You're making this thing faster and faster and faster,
No, we are not done yet.
and you're gonna exceed the speed of sound one day, right? No.
Hopefully, once we keep on going, well, who knows what we'll end up tomorrow. Right
Yeah.
now, the strategy is to keep on pushing towards that big goal in the sky is to go 300 miles.
Yeah.
So that's what he left the gas tank.
So what's the worst thing that's ever happened to you on this bike? You lost a race, or lost a component, or?
No, I've had a wrist pin. Almost get stuck in my calf.
Oh shit! Engine blew up and
Oh, yeah.
a wrist pin, huh?
Piece that blew out the rear tire about 243 miles an hour.
Yikes!
So that was there's a cool video of it on YouTube.
Really? Did you hit the ground, or did you? No.
That's right. That's if that happened, my wife would have
Yeah.
No, we've got to maintain the vertical position.
That's funny. I remember I asked the same question to TJ Zizzo. He's a top fueler, and I said, well, have you ever crashed and how fast were you going? He said he crashed at 300 miles per hour. He opened the latch, he got out, and he goes, my wife hits me harder than that. All the safety in there, I guess, protected him really well. Yeah. No. So, well, thanks for being a brave soul and doing this and going out and setting records. This is an awesome machine you guys have put together here, and I wish you luck and I wish you safety. Hope to see you hit 300 one day.
Thank you. Have a good day.
You too.
Yes, it is, son.
I think this looks like a Ford mod motor. Howdy.
How's it going?
Pretty good. I was impressed by your jewelry. It's really shiny.
Thanks.
Yeah. What am I looking at here? Is this a Ford mod motor?
It's Coyote?
Coyote. Okay. All billet?
No.
Oh, okay. It's just polished.
Yeah, stock block that we had powder coated.
Okay. Stock block, huh? So anything done to it, ported or bored or anything like that, or?
No, just display to highlight the gaskets.
Okay, the gaskets. That's what you guys do. All right. So these are what do you call them? Triple steel.
These are MLS gaskets.
Yeah.
And these are Vulcan cut ring gaskets, so it's a composite with a stainless steel fire ring.
Okay. So benefit of this then is just better clamping at high boost, or?
Yep.
Yeah.
Higher boost levels. Your MLS is for your everyday, all the way up to performance.
Yeah.
Vulcan cut ring will do everyday, but much higher performance.
Okay.
When the copper gaskets are always
Yeah, and then the level above this would be to O-ring the block, right? And yeah, okay. All right, cool products you guys have here. I see the copper ones here. So, with these copper ones, do you ever have to worry about them creeping? Over time, do they get thinner and flatter? Like when you put a penny on the railroad track and you run it over. Does that happen to them? Yeah.
If you see a motor that's been detonated,
Yeah.
really bad, you'll see where the copper settles out.
What happened? You said what happened?
It'll settle down. So if it's gapping over a water passage, it'll actually fall down into it.
Oh, okay.
That's,
Is that just because of this extreme heat, you think, or that's pressure, or what does that?
It's like a detonating hammer.
Oh, just boom. Okay. Yeah.
Motor's toast anyways. at that point. But no, typically a retorque after a heat cycle, the copper gasket is good to roll.
Mm-hmm. And I would think you get better heat transfer with this, maybe, right? No, or
Copper is kind of the standard as far as conductivity goes. So.
yeah, so you can get the heat out of the head a lot quicker.
Yep.
Yeah.
So the copper gasket, you never have to worry about a hot spot on the floor.
Yeah.
But for the most part, copper is going to be your
Remember the singles working on?
way high booster tracks are pulling into your top fuel, your blown alcohol, your big nitrous motors. They're going to run a copper with no ring receiver screw. The extreme boost for street cars, you run a volt recovery, and then your mild boost and mild nitrous setups, and actually aspirate setups, MLS works well.
All right. So tell me price difference between an MLS to a what do you call it, composite one to the
So,
copper.
First piece on the MLS is going to be $85 to $95. The
All right.
covering, you're going to be anywhere from $149 to $179, and for an inline six, closer to $200.
All right.
Retail.
And copper.
Copper depends. Per piece is actually around $60 a piece.
Oh, really? They're that cheap?
Yeah, well, for our flat copper, our ICS is going to be much higher, closer to $90,
Yeah.
$10 a piece.
That's weird that this is cheaper than these, and this is the best, huh?
Yeah, it requires a lot of machine work to get these set up right.
Yeah. Okay. Well, I'm gonna start saving my pennies. I'm gonna melt them and make my own in my house. So, yeah. Take care. Nice talking to you. How do people find out about your products? Where do they go? SCEgaskets.com?
Yes, sir.
Okay, great.
Chevette Jags is the other distributor.
Oh, okay, great. Okay, cool. Nice talking with you.
Thank you.
Appreciate it. Lots of jewelry at this booth here. Some aluminum, forged steel, maybe even some titanium stuff, I don't know. Howdy. Pretty good. I'm filming for my YouTube channel. Can I talk to you guys about some of the stuff you have on display here?
Not our stuff.
No? What do you guys do?
Race.
Oh, you're racers. Okay. I just saw you guys here at the booth in matching shirts, so I thought you were, yeah, okay. They're busy. All right. Well, I guess if they're busy, I could just take some of this jewelry and, walk off of there, right? And they won't know. All right. I didn't know this was a gun show. Look at all these bullet casings they have here. Hey. How you doing? Pretty good. You got some fast stuff here, huh?
Try to.
Yeah. Okay, what do you guys do? Heat shielding, huh?
Shielding and
Okay.
sound deadening.
Yeah.
So the shiny stuff.
Yeah. Okay. So,
Stuff you never see.
because it's so expensive, you mean, or?
Oh, because it's under the hood.
Oh, it's under the hood. I see. Yeah. Yeah. So I didn't realize that. I always thought that heat wrap stuff is just for minimizing heat soak in the engine bay, but then I found out that it actually increases horsepower too.
Yes.
And
the intake temperature. So
Yeah.
Denser air to start with.
Right.
You've got your boost induction.
Yeah, but I also heard that the hotter the exhaust is coming out of the engine, the faster it wants to escape out the tailpipe.
Yes.
Yeah, so you gain a little horsepower there. That's So
Yeah, so you're reflecting heat away from your intakes. And then if you're wrapping your exhaust, you're keeping the heat in there.
yeah,
So it's exiting out faster.
right. So that was something that exhaust scavenging. Yeah, that's yeah. Okay, what kind of car is this? That's a Vet that does what?
Corvette just came from Daytona, placed third. Literally went on the trailer and came here.
Okay, what race series is this in then? Any idea?
I believe mostly GTA 2.
GTA 2.
But then you can even see the TA sticker.
Yeah.
They're in a couple of different classes. It's a team run by ECC Tuning.
Okay. Any idea what happened down there?
No idea. idea, other than
Looks like
some
they
tire rub for sure.
It looks it looks like a tire might have blown and taken out the door and the exhaust and whatever. But it's part of racing. Shit like that happens, right? So
Yep.
thanks for talking with me, man.
Authenticity.
Yeah. Looks like a standard small block in there. Yeah, I don't think that's an LS motor. Holy cow, that's a lot of wires and electrical stuff.
A lot of stuff under the bed.
Oh yeah.
Still lasting it.
Let's check out this car over here.
Going in?
Excuse me. This thing is done up really nice. Like perfect nice. Symmetrical. Blower is like, look at that. The fender, or the whatever you call this piece down here, is, you know, built to accommodate that compressor. Here's another thing that caught my attention right away on these zoomies. Look at the TIG welds on there. I don't even know if my camera's focusing on it, but nice stuff. Nice stuff. So how you guys liking the video and the commentary so far? If anyone has any special requests on what they'd like to see, or let me know, and I'd be glad to take it up and chat with them. It is really busy here compared to yesterday.
You guys on TV? No.
Yeah, not the right time to do it, I think. Right. But I kind of wanted to talk to you if you have
Sorry.